All right, these are the answers to page 528. Triple variables here, and our goal is to try to eliminate one set in order to be able to just get it down to two equations with two variables. And you can see with number 13 here, we already have 3x minus z equals 0. We can kind of put that to the side as one equation that just has two variables. If we could eliminate the y in the other pair, then we could create another set of equations that has just x's and z's, and that's easy enough. What we're going to do is just simply add these two equations together. 1x plus 2x is 3x. Y plus negative y is 0, that goes away. Z plus z is 2z, and 6 plus 3 is 9. So we add those two equations together, that gives us x's and z's, and we already had one that just had x and z in it, so that's kind of a nice thing. So now what I can do is try to eliminate, and the easiest way to do that is just go ahead and subtract these equations. 3 minus 3 is 0, that goes away. Negative 1 minus 2 is a negative 3. 0 minus 9 is negative 9. If you divide, we get z equal to 3, and there's our first answer, okay? Now we're gonna put that 3 back in. We'll put it in right there. We get 3x minus 3 equals 0. If you add 3, divide by 3, we're gonna get x equal to 1. There's our second answer, okay? All right, now let's go ahead and put those, say, into the top equation. So 1 for x, 1 plus y plus 3 equals 6. So that's y plus 4 equals 6, so y equals 2. All right, there's our answers, 1, 2, 3. So not too bad once we can kind of get that. On this one here, number 15, you can see we already have an equation that has x and z, so I'm going to put that to the side here. 2x plus 2z equals 2. And you can see that with the other equation, if I can get rid of this y here with these, then I might be able to create another equation. And that's easy enough. I just have to subtract these two equations. So 5x minus nothing is 5x still. 3y minus 3y is 0. That goes away. That's what we wanted. Nothing minus negative 4z is a positive 4z. That one's you got to be careful about. Okay, it's a positive 4. And then 4 minus 4 gives us 0 there. All right, so this is where we're at. I want something to eliminate, so probably the best thing to do is to multiply the top by negative 2. We'll get negative 4x minus 4z equals negative 4. And then I can add these together. 5 plus negative 4 is 1. This cancels. 0 plus negative 4 is negative 4. I end up with x equal to negative 4. There's our first answer. Okay. Now what I'm going to do is I'm going to put that negative 4 back into the original right here. So I'm going to go 2 times negative 4, that's negative 8, plus 2z equals 2. If you add 8, you get 2z equal to 10. Divide by 2, we get z equal to 5. There's our second answer. All right. And now I can actually use either one of these. It doesn't matter. Let's say we use the middle one. I'm going to put negative 4 into that 5 there. So we'll get negative 20 plus 3y equals 4. Add 20, 3y equals 24. Divide by 3, we get y equal to 8. All right, there's our answers. Negative 4, 8, and 5. Okay. For 18, we don't have the luxury of having an equation that would just cancel, that's already missing stuff. But we do have something that's kind of nice. You see this negative 4y? It will eliminate the y here, and it would eliminate the y here. So we're going to just go ahead and do those two things one at a time. First, we're going to add these equations together. We'll get 4x, y's will cancel. Negative z plus 2z is 1z. And 7 plus negative 6 is 1. All right, so we add those together, that happens. And then we're going to add these together. So 2x plus 1x is 3x. These y's cancel. 2z plus z is 3z equals negative 6. All right, so we get to here. Now our goal is to try to get something to cancel, and probably the easiest way to do that is to multiply the top by negative 3. We get negative 12x, negative 3z equals negative 3. All right, put it together, get negative 9x, this goes away, and this is negative 9. That gives us x equal to 1. Okay. Now, put that 1 back in. Let's say we go right here. 4 times 1 is 4 plus z equals 1. If you subtract 4, we get z equal to negative 3. Okay? Now let's take the 1 and the negative 3, and you could pick any of these 3. It does not matter which one you go to. We're going to try to solve for y. Let's just go to the top. So I'm going to go 2 times 1 is 2 plus 4y minus negative 3. So minus negative 3 will turn that into a plus 3 equals 7. All right, and 2 and 3 make 5 plus 4y equals 7. Subtract 5. Divide by 2, we get y equal to 1/2, and there's our third answer. All right. So again, not too bad there, just kind of walking through that. 44 wants us to create a quadratic equation that goes through these 3 points here. Now, a quadratic equation in its general form would be ax squared plus bx plus c. We'd have y equals this, right? And we're trying to figure out what these 3 numbers would be. So what we're going to do is we're going to put 0 in for x, and we're going to put 3 in for y, and we're going to try to create some equations here. So if I do that first here, I have 3 equals a times 0 squared, so that'll be 0, plus b times 0, that'll be 0, plus c. So actually we get the first of the numbers right away. We get c equal to 3. And we'll just go ahead and use that then for the other 2 equations. Let's go ahead and go here. We're going to put 4 in for y, so 4 equals, put 1 in for x. 1 squared is 1. 1 times a will be a, plus 1 times b will be b, plus c, which we found out was 3. Okay, so if we just subtract this, this will give us a plus b equals 1. All right, so there's one equation for between a and b. Now we'll do the same thing here. Let's put 2 in for x and 3 in for y. So 3 equals 2 squared 4. 4 times a is 4a. 2 times b is 2b plus c, which we know is 3. If we subtract that, we get 4a plus 2b equals 0. All right. Here then are our 2 magic equations that we're going to use to solve for a and b. We can do substitution, elimination, doesn't matter. It's kind of up to us. I'm going to go ahead and multiply everything by negative 2. It gives me negative 2a minus 2b equals negative 2. And then we're going to add these together. So this is 2a, this goes away, this is negative 2. And we get a equal to negative 1. Okay, so we lock that in. If I put that back in, negative 1 plus b equals 1, so b equals 2. All right, we got our a, we got our b, we got our c. So negative x, so y equals negative 1x squared plus 2x plus 3. That's our equation for that. And that'll go through all 3 of those. If you graph that, you'd hit all 3 of those points there. All right, then the last one we had you look at is number 53, dealing with this. 3 different types of loans that came off of a total of $775,000 borrowed. All right, so one thing is, what we're gonna do is make sure we know what our variables represent. So we're gonna let X be the amount of money that came from the 8% loan, Y will be the amount of money that came from the 9% loan, and Z will be the amount of money that came from the 10% loan. So these are actual amounts of money, just to help us kind of keep this straight. And the total amount of money that we borrowed was $775,000. So X plus Y plus Z is equal to $775,000. We know that for sure. Now, when we say that X is the amount from the 8% loan, that means you're going to be paying 8% of that amount on top of the, so in other words, if you borrowed, say, $100, you're going to pay that $100 back plus 8% of that. So you'll be paying back, in a sense, $108 for the right to use that money for whatever you needed it for. All right. Same thing for the 9%. You're going to pay back 9% of that in interest, and for the 10%, same thing. So we're doing 8% of X, 9% of Y, 10% of Z. That's our total interest, which we were told was $67,500. Okay. And then finally, what we have is the fact that the amount of money that we spent, that we borrowed from the 8% is 4 times what we borrowed from the 10%. So X is 4 times whatever Z was, okay? Now, what I think what would be helpful here, what would be manageable, is to take this 4Z and put that in for X here and here. So if you do that up top, you'll get 4Z plus Y plus Z equals 775,000, which means Y plus 5Z equals 775,000. Okay, so there's kind of that'll lock that in right there. That's one equation. Let's do that on here, and if we do that, we get 0.08 times 4Z. That's 0.32Z, all right, plus 0.09Y plus 0.1Z equals 67,500. Put that together, we're going to get 0.42Z plus 0.09Y equals 67,500. Now, what I'm going to do is two things. We're going to flip the Y and Z so that they're the same as this, but we're also going to multiply everything by 100 to get rid of these obnoxious decimals. So 100 times that will give us 42Z, 100 times that will give us 9Y, and then 100 times that will give us 67500 and two more zeros. 6,750,000. All right, here are two equations. They're kind of big and obnoxious, but that is what we're working with, and the best thing to do to solve them would be to multiply by -9. It'll give us a -9y minus 45z equals 775,000 times -9. Negative 6975000. All right, so we're going to take that and add that to 750,000. Okay, we get a negative 225,000 equals a negative 3z. All right, so divide by -3, and z is $75,000. Okay, that's how much we borrowed from the 10%. So we borrowed, or somebody borrowed, 75 grand at 10% interest. Okay, we were told that the 8% was 4 times this. So if we multiply by 4, that means the X, the amount of money we borrowed at 8% was 300,000. Okay, and then we were told that the total amount of money was 775. So if we take 775 minus 300 minus 75, it should leave us at 400,000 that we borrowed at 9%. Okay, kind of a tough problem, but that's how you set it up and solve it.